Hello dear friends, this is Mr. Srinivasan who is having more than 30 years experience in this construction industries, trying to present you a small presentation on how to prepare a bar bending schedule for the column. What is meant by a bar bending schedule? Bar bending schedule is nothing else which identifies the bar shapes, sizes, marks, etc. as mentioned in the structural drawing. The process is called as scheduling. Sample of a bar bending schedule. The attached image will give you a brief idea about how to prepare a bar bending schedule. Guidelines to be followed in the BBS. The bars should be grouped together for each member, such as beams, columns, etc. Cutting and bending schedules should be prepared in a separate format. The form of the bar and schedule of the shape should be as per IS 2502. The bar should be listed in the schedule in a numerical order. The bar mark reference helps the bar benders to identify the bars and the location so that he can place it in a proper position as shown in the drawing. Bar bending schedule is generally prepared by an engineer or a quantity surveyor. Bar bending schedule helps the quantity surveyors to know the number of bars required for each bar types and helps him in preparing the bills. It also helps the engineers to check at the site regarding the bar positioning, etc. How to prepare column bar bending schedule? First of all, there are some standards and assumptions that has to be met while making bar bending schedule for a column. Loads acting on a columns. Hope you recognize the traditional load action on a column. Take a look at the adjoining diagram. There is a various load, namely axial loads, column internal force, momentum diagrams, and everything has been acting in the column, which has been explained in the diagram. Bar bending schedule of the column. Never tie a column at a pinnacle and a backside where the integral moment is high. Always tie the column at the center. Minimize the cutting of a bar and lapping as possible as. Always lap alternative bars at a time. Always overlap top bars with the bottom bars. Maintain sufficient end to stop spacing between the layers. The adjoining diagrams will indicate you the building heights. It consists of a ground floor and 3 floors. Ground floor height is between 3 meter 3 inch so, and other 3 floors are 3 meters each with a slab thickness ranging from 125 to 100 mm. Vertical bar calculation. From the diagram, you know slab thickness 125 and 100 mm. Floor to floor height is 3 meter. Ground floor height is 3.3 meter. Footing thickness is 300 mm. Development length is 50 dia. Column has 6 numbers of 20 dia bars. 8 mm stirrups at the rate of 150 mm center to center. Footing clear cover 40 mm. Slab clear cover is 25 mm. And column cover from the stirrup is 25 mm. Calculation methodology. Step 1. Find the length of the vertical bar. Length of the vertical bar is equal to development length plus height of a ground level plus floor heights plus slab thickness plus terrace slab thickness of 100 mm plus overlap length as mentioned in the detail B, which means 50 into 20 plus 3300 plus 3 into 3000 plus 3 into 125 plus 100 plus 50 into 20. This makes a total length of 14.775 meter, let's say 14.78 meter. Now we know the length of one vertical bar. Normally, column reinforcement drawings shall not show the lapping details. Find out lapping. As we are all aware, lapping length is generally required as a 50 dia. That is 50 into diameter of the bar. In our case, it is 50 into 20. It is in 1000 mm, say 1 meter. So the number of length of the bar is 12.25 meter. So total length of the vertical bar is 14.2 meter. For an additional of 12.25 meter, we have to make the lap length to achieve the total length. So we have delivered the lapping size with the whole size of is equal to 14.775 plus 1 meter, that is 15.775. Let us say 15.78 meter. As we stated earlier in the post, consideration on the factors which lapping the bar. There is no one correct technique we can use. Just take into account the lines. Never tie a column at a pinnacle or a bottom. Always top at alternative bars. Always overlap top bars with the backside bars. How to calculate the stirrups? Length of one hook is 9 dia. Refer the shown drawing, which will give you the rough idea of the length and breadth and a hook and everything. Whenever you are tying a reinforcement, you have to calculate less 45-degree bend 1 dia, 90-degree bend is 2 dia, and 135-degree bend 3 dia of the bar. Cutting size of the stirrup is equal to perimeter of the stirrups minus number of the bends plus number of the hooks. In our case, 2 into A plus B, that is the width plus length, minus 3 numbers of 90 dia 90 dia hooks plus 2 number of hook cover hooks. Length is equal to 2 into 450 is equal to 900 mm. Width is equal to 2 into 150 is equal to 300 mm. Plus 18 dia hook is 164 mm. Minus 3 numbers of a 90-degree bend, that is 48 mm. Which makes the cutting length of 1.316 millimeter. Number of stirrups. Number of stirrups is required is equal to total length of the column divided by the spacing of the bar plus 1, which is known as n plus 1. In our case, it becomes 85 numbers. The detail has been shown. Bar bending schedule. How to prepare a bar bending schedule has been shown as per the sketches. Vertical bar of 20 mm, 6 numbers of a bars, cutting length 14.2 meter, total length 85.2 meter. Cirrus bars 8 mm, 85 numbers, 1.316, 111.6 meter. Step 6. How to calculate the total weight. Vertical bar 85.2 meter, dia of the bar is 20, which is having a unit weight of 2.47 kgs, so it makes 210.44 kgs. Stirrups, total length is 111.86, 85 numbers of the stirrups has been required with a unit weight of 0.395 kgs, 63.15 kgs. So total weight is 273.59 kgs. Thank you for watching this presentation. In case you like the presentations, kindly like, share and subscribe so that I can give you furthermore wonderful ODS. In case of any clarification required, do not hesitate to write to us. Thank you once again.